This project began on page 89 of your ignition manual. You did logic in the CCW manual for a 3-conveyor system. We kind of enhanced the logic in the ignition manual. We showed you the logic to use. It begins, like I said, on page 89. And we had a lot of multi-state indicators. So the conveyors were multi-state indicators sized to look like the top view of conveyors. So the logic, and by the way, I want to mention that I noticed on page 106, you see here conveyor 2 full, photo I1 empty, a rung here. If you look at this logic, you've got a true if on, true if off, energize output. However, if you look at the logic for sequence here, on page 110, you see an extra instruction thrown in there. Obviously, I put it in there. I don't remember why, but it doesn't need to be there. So you want to delete, if you did this from the manual, you want to delete this instruction right here, is branched around conveyor 2 underscore full underscore 1 PE underscore gravity exit, energize output conveyor 2 full underscore 1 PE empty. So you want to delete this equal instruction here in order to get the logic to work correctly. To demonstrate this screen, what we're doing is we're running cartons through this conveyor system. Now remember, in the real world, you wouldn't have this level of animation and cartooning with cartons appearing on the conveyors. You would probably have the conveyor count right here, this numeric indicator. You would probably have it in the middle of the conveyor to show you how many cartons were on the conveyor. You wouldn't actually be displaying cartons, but just for fun, we had you add cartons. I'm going to turn on photo I1 and it pops up a carton here. Now remember, you drew these cartons, and after you drew the first one, then you copied and pasted it. You had 4 of them on each of the conveyors, equally spaced out, and then you wrote logic to control the visibility. To operate this, a carton would come down the gravity conveyor, and when it hits photo I1, the gravity stop is going to pop up to prevent cartons coming down the gravity conveyor from bumping into the back of this first carton. It keeps them singulated. We don't want them pressed up against each other. As soon as this carton broke the optical path of 1 PE, and we simulate this with these buttons down here. Since we don't actually have photo eyes, we don't actually have conveyors, we have to simulate it. These multi-state indicators here, 1 PE, 2 PE, and so forth, they just show you the state of the photo eyes as the logic sees it. We're turning on and off the photo eye right here with this button. So if I click on that, the visibility for that carton is activated through the tag, and it shows a carton there. And it also turned on conveyor 1. Now, in real life, this carton would be up against the edge of that conveyor 1 belt, and it would get pulled onto the belt, and eventually it would block photo I2. We'll turn on photo I2, and nothing changes in the animation, but the sequence to get a carton onto that conveyor, I'm going to turn 2 PE back off, 1 PE off, and notice when I do, now I see a carton on there. Now, if at any point when you're running this, you want to start over, just select the counter, put in 0, and you've got 0 cartons. And then you can always stop the system, restart it, and start from scratch. The sequence to get cartons to go from one conveyor to the next is to have it break the exit of the previous, then block the optical path of the next conveyor, and right now it's being pulled onto this conveyor. It would clear 1 PE. When it clears 1 PE, it disappears because it's still blocking 2 PE. When you clear 2 PE, then the carton appears on conveyor 1, the conveyor stops. Now, if we were using paths and animating, we could actually have the carton in full view for the whole path. We're not trying to do that. We're just giving you something to play with, controlling visibility of an object, because you had to write logic to make these cartons appear in these locations. We have another carton coming down the gravity conveyor, coming down. It hits 1 PE. Now it turns on conveyor 1, gravity stop pops up. In real life, this carton that first came on conveyor 1, it would be moving ahead and it would be pulling on the next carton. So there's several ways we can do this, but we will pull it onto conveyor 1, have it clear the gravity conveyor, and then clear 2 PE. And now we've got 2 cartons and it stops, because remember, we're buffering cartons. That's the sequence at the transition between gravity conveyor, conveyor 1, conveyor 1, conveyor 2, conveyor 2, conveyor 3. You break the beam for 4 PE, then 5 PE, then you clear 4 and clear 5. Now, we don't have a carton sitting here. Let's go back and bring down a third carton. It's moving them all ahead. We clear 1 PE, then we clear 2 PE, and now we got 3. We'll do that again. Fourth carton comes down. Now we're instigating conveyor 2. We block 2 PE, clear 1, clear 2, and now we've got 4. It depends on what you put in for full for the conveyors. If the conveyor logic says it's full, then we'll send one on here by turning on 4 PE, then 5 PE, turn off 4, and on 5. See, now it stops. So 3 is full. If there's 3 cartons on there, it's full, and you can change that in the logic. If we keep doing that, another one comes down. Now notice both conveyors are running. Conveyor stop pops up. We keep moving. We block 2. We clear 1. We clear 2. Now this one is also moving. We need to pass one through 4 and 5. We turn on 4, turn on 5, turn off 4, turn on 5. And we just keep on doing that. Another conveyor carton comes down the gravity conveyor, turn on 1, turn on 2, turn off 1, turn off 2, turn on 4, turn off 5, turn off 4, turn off 5. Next time we're going to see something a little different. Well, and remember, you're operating these photo eyes manually with these buttons down here. And you can't do it synchronous like would happen on real conveyors, because when these conveyors turn on, we would be clearing, we would be blocking 4 PE and 6 PE. Technically, we would have 1 PE, 4 PE, and 6 PE blocked simultaneously, but we can't do that with these buttons down here. Let's bring another one down. Now notice that 3 conveyor turned on because conveyor 1 and conveyor 2 are full, because we said 3 is a full count. So block 2, clear 1, clear 2. Now we've got to go down here and block 4, then 5, clear 4, clear 5. Now see, we got 4 on here. So block 6, block 7, clear 6, clear 7. And on you go. That's all there is to it. This is not perfect logic. It's not a perfect HMI project. We just wanted to give you something to play with, to entertain yourself. So you could treat this screen, this HMI in ignition, as a training system. In other words, you develop a virtual process, you write logic for it, and the virtual process is the HMI. Now, I was doing these transitions between conveyors one at a time. Block 1 PE, block 2, clear 1, clear 2, and so forth. But you could, In this situation, if another one comes down on the gravity, you could block one. This conveyor turns on block 4. This photo I turn on 4, turn on 6, then go back and turn off 1. In other words, you could block 1, 4, and 6, then block 2, 5, and 7, and then go back and clear 1, 4, and 6. And technically, that would be more realistic. So enjoy playing with this.